stone tool can be as sharp and symmetrical as a modern blade, yet be older than writing itself. This is the core of a profound historical mystery, the discovery of traces of precision tools in ruins older than writing. By the end of this exploration, you will have a new framework for understanding the true capabilities of our ancient ancestors. We will examine artifacts of impossible geometry from deep within Egyptian tombs and monolithic pillars carved over 11,000 years ago. How did cultures without metal or the wheel achieve such flawless stonework? And what does their forgotten skills say about the story of human progress we all think we know? What does it mean for our history when the stones tell a more advanced story than the textbooks? The mystery begins not with a grand theory, but with a simple, tangible question. What exactly are we looking at when we speak of ancient precision tools? In our world, the word precision conjures images of computer-guided lathes and laser calipers, machines that can carve metal to tolerances measured in thousandths of a millimeter. That is not what we find in these ancient ruins. Instead, we find something perhaps more astonishing, because it was achieved without any of that. The precision we are searching for in the deep past is defined by a consistent, almost unnatural mastery over materials. It is seen in objects that possess complex symmetrical geometry, where curves are perfectly uniform and flat surfaces are flawlessly level. It is evidenced by cuts into stone so hard, like granite or diorite, that they would be a challenge for modern tools without diamond-tipped blades. It appears in the form of drill holes that are perfectly cylindrical, with spiraling grooves so regular they suggest a stable, powerful rotation. Think of the famous stone boxes within the of Saqqara in Egypt, massive sarcophagi carved from single blocks of granite. Their corners are sharp, precise right angles, their interior surfaces polished to a glassy smoothness, and their lids fit with a seam so tight it is difficult to slide a piece of paper between them. Or consider the multitude of pre-dynastic Egyptian vessels, bowls and vases carved from brittle stone like schist or basalt, with walls so uniformly thin they appear translucent, and shapes so symmetrical they seem turned on a wheel, yet they predate the invention of the potter's wheel itself. These artifacts do not display the rough, percussive marks of someone bashing a rock with another rock. They show the controlled, repeatable marks of a technique, a lost method that applied force with incredible consistency and control. This is the enigma. This level of technical skill and repeatable results is what we associate with advanced, literate civilizations, with engineering and written plans. Yet here it is, embedded in stone older than the earliest known writing systems. The tools themselves may be lost to time, but their fingerprints are everywhere, pressed permanently into the hardest materials our ancestors could find. They left behind a signature of mastery, and that signature is what compels us to look deeper, to ask how, and more importantly, why such effort was expended in a world we are told was just learning its first steps. The signature of that lost mastery is carved into the very bedrock of a windswept hill in Turkey. At over 11,000 years ago, something extraordinary took shape. This is not a city or a fortress, but a series of vast, circular enclosures defined by massive, T-shaped limestone pillars, each one hauled from a nearby quarry and erected with a purpose we can still only guess at. The sheer scale of moving stones weighing over 20 tons is a feat that commands respect, but it is the finesse, the undeniable precision in the details, that transforms awe into a deep, lingering mystery. Look closely at the surfaces of these monoliths. Etched into the stone are elaborate bas-reliefs of foxes, boars, cranes, and scorpions. The lines of these carvings are not shallow scratches or the uneven marks of a stone being chipped away by another stone. They are crisp, deep, and controlled, with smooth contours and sharp edges that have survived the march of more than 400 generations. This is not crude symbolism. It is artistry executed with a confident, steady hand, suggesting tools that could remove stone with predictability and control. Yet the most telling clues to their technical capability are not the artistic carvings, but the functional ones. Carved directly into the solid bedrock floor of these enclosures are perfectly circular sockets. Next to them, on the bases of the towering pillars themselves, are corresponding tenons or protruding knobs shaped to fit neatly into those holes. These are not rough, hacked-out depressions. They are engineered features, mortise and tenon joints in stone, designed for precise alignment and stability. Creating a perfect, clean circle in solid limestone, and then shaping a matching protrusion on a separate multi-ton block to slot into it requires more than strong arms. It requires planning, measurement, and a method of cutting and shaping that allows for repeatable, accurate results. This is the language of joinery, of carpentry, but translated into the most durable material possible. And this is where the conventional timeline of human progress begins to strain. Was built by people we classify as hunter-gatherers, a society that existed long before the invention of pottery, let alone metal tools, the wheel, or written language. According to the traditional narrative, these were small, mobile groups focused solely on day-to-day survival. They should not have had the surplus labor, the organizational structure, or the technical know-how to coordinate the quarrying, transportation, precise shaping, and erection of these monumental pillars. The site forces a simple but revolutionary question. What kind of knowledge, what kind of social cohesion, and crucially, what kind of tools did these people truly possess? The clean lines and perfect circles are a silent argument carved in stone that a chapter of human ingenuity, a chapter concerning precision and planning, may have begun far earlier and been far more sophisticated than our history books have ever dared to suggest. But the stone circles are only one chapter in this global mystery. To find the next, we must travel thousands of years forward and many miles south, to a place where the mystery is not carved into open air, but sealed in profound darkness. Beneath the sands of Saqqara in Egypt lies a place called a long, echoing corridor deep underground. Here, in silent niches cut into the living rock, rest objects that defy simple explanation, dozens of colossal boxes carved from a single, solid block of stone. But these are not rough-hewn containers. They are made from granite and diorite, some of the hardest stones on the planet, materials that would quickly dull modern steel tools. And yet, the surfaces of these sarcophagi are not merely smooth, they are flawlessly flat. Their corners are not approximate, they are perfect 90-degree angles, sharp and precise from the outside in. Even the interior corners, where two flat planes meet inside the box, are sharply squared, a technical nightmare to achieve with hand tools. The most telling detail, however, is the fit of the massive lids. Each multi-ton lid was carved to sit perfectly atop its box, and the seam between them is so exact, so immaculately engineered, that you cannot slide a piece of paper between the surfaces. This is a level of precision we associate with modern machine shops, with surfaces planed by computer-controlled cutters. The mainstream explanation points to incredible patience, using copper saws with an abrasive slurry of sand and water to slowly, over years, grind the stone into shape. And while this method certainly works, a growing number of engineers and stoneworkers look at the boxes and voice a persistent doubt. The sheer consistency of the finish, the uniformity of the flat planes, and the perfection of those interior right angles suggest something beyond patient sanding. They hint at a process that applied tremendous, controlled force with stability, a method that could remove material evenly and predictably, perhaps even a form of primitive machining or a lost technique for softening or working stone that we no longer understand. These boxes are not art. They are industrial-grade precision, buried in a tomb older than the Great Pyramids. They sit in the dark as polished, silent witnesses, not to a pharaoh's glory, but to a forgotten standard of craftsmanship, a standard that asks us how a culture with supposedly simple tools could achieve a finish that still challenges our assumptions today. Granite does not yield easily to persuasion. This is the fundamental, physical truth at the heart of the mystery. To understand why these ancient artifacts are so perplexing, we must first understand what their creators were up against. The The stones they chose to master, granite, basalt, diorite, are not just rocks. They are some of the most stubborn materials on Earth. On the scale of mineral hardness, which ranks materials from 1 like talc to 10 like diamond, these stones sit between 6 and 8. For comparison, the copper tools that mainstream archaeology tells us were available to early cultures like dynastic Egypt rank around a 3. This is not a minor difference, it is an overwhelming one. A copper chisel struck against granite would not cut it. The copper would simply deform, flatten, and become useless. So how did they do it? The accepted theory is one of abrasion, not cutting. The idea is that artisans used a slurry of wet sand, which contains quartz particles harder than the copper, as a grinding paste. A copper saw, or even a piece of wood or stone, would be dragged back and forth, the abrasive sand slowly wearing a groove into the granite over what must have been an unimaginable length of time. This method works, and it explains a great deal of the evidence. You can see the long, straight striations on some stone surfaces that match this back-and-forth sawing motion. The immense labor and patience required is a testament to human dedication. But then we return to those specific, puzzling features, the ones that seem to strain this explanation to its breaking point. Take the deep, straight, and narrow incisions found on some artifacts, or the famous drill holes in granite that are not just round, but perfectly cylindrical, with spiral grooves so uniform they look machined. Using a loose abrasive slurry with a handheld tube to drill creates a tapered, irregular hole as the abrasive wears away the sides unevenly. The holes we find are not like that. They are straight-walled and precise. Then there is the polish. On some artifacts, like those mysterious stone boxes or certain pre-dynastic vessels, the surface achieves a near-optical, mirror-like finish. Achieving this with sand alone is extraordinarily difficult, as sand particles themselves fracture and create microscopic scratches. It suggests a final polishing stage with a finer, more consistent abrasive, or perhaps a technique we have not yet considered. This is the core of the technological enigma, a persistent gap between the tools we believe they had and the flawless results they undeniably achieved. It is the discrepancy that refuses to be smoothed away by conventional explanations alone. It pushes us to wonder if we have underestimated their ingenuity, if somewhere in the fog of deep time, a different principle, a different method for persuading stone to obey, was discovered, mastered, and then ultimately lost, leaving only its perfect products behind for us to question. The most damning evidence for a lost technology is often found in the scraps. To understand a craft, do not look only at the masterpiece on display, look at the workshop floor, at the broken tools and the discarded. In the context of ancient stonework, these overlooked fragments tell a story the finished monuments cannot. Scattered across ancient Egyptian quarries and building sites, particularly around Giza, lie granite blocks that were never used. On their surfaces, you can see the clear, parallel grooves left by the saws that were cutting them. These are not the wandering, uneven scratches you would expect from a man laboriously dragging a copper blade back and forth by hand, with sand slurry as an abrasive. These marks are straight, deep, and remarkably evenly spaced, as if the cutting implement was held in a rigid, guided frame, applying consistent pressure with each pass. The spacing between the grooves is so uniform it suggests a mechanical feed, a way to advance the cut a precise amount with each stroke. This is the difference between drawing a straight line freehand and using a ruler, the difference between craft and something approaching industry. But the single most provocative piece of evidence is not a saw mark. It is a leftover from a different process entirely. In museum collections, like the renowned museum in London, you can find objects known as granite drill cores. These are the solid cylinders of stone that remain after a hole has been drilled into a block. One famous core, extracted from a site at least 4,000 years old, is particularly illuminating. The surface of this granite core is not smooth or irregular. It bears a continuous, elegant, helical groove spiraling down its length, like the thread on a very large screw. This groove is the fingerprint of the drill bit that created it. The implications of this simple pattern are profound. First, the groove is uniform in its depth and pitch, meaning the drill was not wobbling or being pushed inconsistently. It was stable. Second, the rate at which the drill bit advanced into the stone, what engineers call the feed rate, is constant. The spiral tightens in a predictable way, indicating the drill was sinking into the incredibly hard granite at a steady, controlled pace. Now, try to replicate this with the tools we traditionally assign to these ancient people. The standard model is a hollow tube, perhaps of copper, spun by a bow string or by hand, with sand and water as an abrasive. If you try this, what happens? The tube wobbles, the pressure from your hands varies, the abrasive slurry is uneven. The resulting core, if you could even extract one from granite, would show a chaotic, rough surface with an irregular, tapering shape. It would not and could not show that perfect, machined-looking spiral. The core in the museum tells a different story. It suggests a drill that was mounted securely, that rotated with immense and stable power, and that was fed downward with mechanical consistency. It is a signature in stone that closely resembles the result of a modern, fixed drill press, not a handheld tool. This is not speculation about artistic style or cultural purpose. This is forensic data, physical geometry locked into the material itself. The waste product, the discarded core, becomes an unimpeachable witness. It testifies to a process, a method of shaping stone that involved more than patience and sand. It points to principles of stable rotation and mechanical advantage that we do not traditionally grant to these ancient builders, principles that would allow them to interact with granite not as an implacable foe, but as a material that could be worked with predictable, repeatable precision. High on the windswept Bolivian Altiplano, at an altitude that leaves visitors breathless, lies a scattered field of stones that may be the most articulate argument for a lost precision. This is Puma, part of the ancient complex, and here the mystery shifts from perfect surfaces to impossible geometry. The ground is littered with massive blocks of andesite and red sandstone, some weighing over 100 tons. But these are not simple, rectangular slabs. They are intricately carved puzzles, each one a unique piece of a larger whole that we can no longer fully see. The defining feature of Puma is a system of interlocking stonework so advanced it feels anachronistic. The edges of these giant blocks are not just straight, they are meticulously engineered with a series of precise notches, channels, and protruding tabs. They were designed to fit together, stone locking into stone, without the need for mortar, like pieces of an immense, earthquake-resistant jigsaw puzzle carved from the hardest rock. Look at any one of these H-shaped blocks, and you will see a level of planning that transcends simple craftsmanship. Each cut is clean, each interior corner a perfect right angle, each flat surface smooth and uniform. Some stones feature complex, repeating patterns of small, precise depressions, as if they were meant to accept modular attachments. The uniformity across dozens of these massive blocks is the real clue. It is one thing for a single artisan to carefully shape one complex stone over many months. It is another thing entirely to produce dozens of these stones, each with its own unique but equally precise set of cuts and fittings, and have them all align perfectly in a grand architectural scheme. This kind of repeatable, interchangeable precision strongly suggests the use of templates or jigs, a form of standardization we associate with manufacturing. Think of it like this: if you were building a wooden cabinet with complex joints, you would not measure and cut each piece freehand. You would create a pattern, a guide, to ensure every cut was identical, so that all the pieces would fit together seamlessly when assembled. The stones of Puma whisper that its builders operated on a similar principle, but at a monumental scale and in unforgiving stone. The conventional explanation of stone hammers, bronze chisels, and endless patience struggles to account for this systematic, almost industrial approach. How do you maintain such flawless geometric consistency across hundreds of tons of hard stone using only percussive tools? How do you ensure that a block carved at one end of the quarry will fit perfectly with a block carved at the other, unless you are working from a shared, precise plan, a common standard of measurement and angle? This site, older than the Inca by over 1,000 years, presents a vision not of brute force, but of sophisticated pre-planning and a masterful, controlled technique for shaping stone. It is as if the builders were thinking in three-dimensional blueprints, translating complex architectural designs directly into solid rock with a confidence and accuracy that still defies easy explanation. The ruins do not look like a construction site that was abandoned. They look like a meticulously engineered machine that was taken apart, its components scattered by time, leaving us with the individual cogs and gears of a technology we can scarcely comprehend. The fingerprints of this forgotten precision are scattered across the globe, a silent testament that this was not an isolated phenomenon. Far from the deserts of Egypt and the high plains of Bolivia, other ancient sites whisper the same puzzling story. On the Mediterranean island of Malta, a labyrinth lies hidden beneath the ground, the hypogeum of, carved from solid limestone around 3600 BCE. This is not a natural cave, but an astonishing feat of subterranean engineering. Its chambers are stacked on multiple levels, connected by stairways and passages, all excavated with an almost architectural intent. But it is the details that resonate with our mystery. The walls are smoothed to a uniform finish. Niches and doorways are carved with clean, straight edges and perfect right angles. In one chamber known as the Oracle Room, a small niche is carved at a specific height, and if you speak into it, your voice resonates and amplifies, projecting throughout the entire underground complex. This is not an accident of excavation. It is acoustical engineering carved directly into the rock, requiring an intimate understanding of sound waves and the properties of stone, a knowledge that seems impossibly sophisticated for its era. Across the Atlantic, in the dense jungles of Costa, hundreds of stone spheres present a different kind of geometric perfection. Ranging from the size of a bowling ball to over 2 meters in diameter, these objects are carved from hard stone like granodiorite. Their purpose remains one of archaeology's great enigmas, perhaps astronomical markers or symbols of status. Yet their most immediate feature is their shape. Many of these spheres are not just roughly round, they are mathematically near perfect, with a surface smoothness and sphericity that challenges the idea of them being shaped with simple stone tools. Creating a flawless sphere freehand from a block of hard stone is an extraordinarily difficult task, one that implies the use of measuring techniques, a method for checking curvature, and a controlled process for removing material evenly from all sides. They are artifacts of pure, abstract geometry, left behind by a culture that left no written explanation. Then there is the curious case of metallurgy in ancient India. Standing in Delhi is the pillar, a column of wrought iron forged in the 4th century CE. It stands over 7 meters tall and weighs more than 6 tons. The engineering of forging such a large, single piece of iron is impressive enough, but its true marvel is its defiance of time. For over 1,600 years, through monsoon rains and humid seasons, this iron pillar has not rusted. It bears only a thin, stable patina. Modern analysis suggests its creators used a unique process, incorporating a high phosphorus content and creating a protective passive layer at the metallurgical level. This is not a lucky accident. It is evidence of a sophisticated, empirical understanding of materials science that was far ahead of its time. What are we to make of this scattered tapestry, these pockets of high technical skill appearing in Malta, Costa, India, and beyond? One interpretation is that human ingenuity is a powerful, universal force, capable of sparking brilliant advances independently in different corners of the world when conditions are right. Another, more speculative line of thought wonders if these are not independent inventions at all, but distant echoes. Could they be the surviving fragments of a much older, foundational body of knowledge, a common source of technical understanding that was carried, shared, or rediscovered by different cultures across, long before the first clay tablet was ever inscribed. The artifacts themselves do not answer this question, but they collectively pose it with increasing urgency. They stand as stubborn outliers, refusing to fit neatly onto a simple, linear timeline of human progress, inviting us to reconsider just how much we have forgotten about our own deep past. Granite yields to persistence, not just to force. This is the cornerstone of the mainstream archaeological perspective, a viewpoint built not on mystery, but on demonstrable human skill. When confronted with these perfect stone boxes and symmetrical pillars, conventional scholarship does not see evidence of a lost machine, but rather the magnificent signature of the patient artisan. The argument is elegant in its simplicity, and it is grounded in a powerful principle. We must not underestimate what dedicated human hands, guided by generations of accumulated knowledge, can achieve over vast stretches of time. For these researchers, the key ingredients were not exotic technologies, but abundant labor, meticulous technique, and a cultural imperative that valued perfection in stone above all else. They point to the social structures of early civilizations, like that of Old Kingdom Egypt, which could marshal thousands of workers for monumental projects that served religious or state purposes. In this context, spending a decade to shape a single sarcophagus was not an engineering puzzle. It was a sacred duty, an act of devotion that justified any amount of effort. The proof of this concept comes from a field known as experimental archaeology, where modern craftspeople attempt to recreate ancient artifacts using only the tools and materials believed to be available at the time. These experiments have shown remarkable results. Using a simple copper saw, a slurry of quartz sand and water, and a great deal of patience, artisans have successfully cut granite. By dragging the saw back and forth, the abrasive sand particles embedded in the copper do the real work, slowly grinding a groove into the stone. Over months or years, a block can be cut. Smoothing a surface to polish follows the same logic, using progressively finer abrasives, from coarse sand to powdered emery, to wear the stone down to a glassy finish. The straight, parallel saw marks found on quarry blocks are explained as the natural result of this consistent, linear motion. Even the famous drill cores with spiral grooves can be replicated, to a degree, by using a hollow tube spun with a bow drill and fed with abrasive slurry. The tube's slight wobble and the settling of the abrasive potentially creating a helical pattern. From this viewpoint, the perfection we marvel at is not a symptom of advanced machinery, but the natural endpoint of a cultural tradition that refined its methods over centuries. Each generation of stoneworkers would pass down subtle improvements, better ways to mix the slurry, more effective sawing motions, or clever techniques for checking flatness using water or stretched cords. What we see as impossible precision is, in this light, the pinnacle of a very long, very focused artistic and technical evolution. It is a testament to the human capacity for specialization, where a class of master craftsmen could devote their entire lives to mastering a single material, achieving a level of skill we can scarcely comprehend in our age of rapid, machine-assisted production. This perspective offers a comforting continuity, placing these wonders firmly within the known narrative of human progress. It tells us that our ancestors were not so different from us, that with enough time, motivation, and organized effort, they could shape their world with a mastery that still takes our breath away. The stones, in this reading, are not clues to a forgotten science, but monuments to the enduring power of the human hand and the disciplined human spirit. Yet the patient artisan theory, for all its elegance, cannot silence every question. A persistent, alternative current of thought flows from the very same stones, reading the evidence not as a testament to simple tools, but as a whisper of something more. This is the hypothesis of lost advanced technology. Its proponents look at the same drill cores, the same flawless surfaces, and ask a different question. Could these results be the product not of infinite patience, but of superior, forgotten methods? They argue that the material evidence itself points toward tools that provided mechanical advantage and consistent power, tools we might classify as primitive machines. A lathe, for instance, could explain the perfect symmetry and concentric grooves found on some stone vessels. A stable, weighted drill press could account for the uniform feed rate and perfect cylindrical holes in granite. The straight, parallel saw marks on quarry blocks could suggest a rigid, guided frame, not a handheld blade. This perspective does not necessarily envision microchips or electricity, but rather a sophisticated application of basic principles: leverage, rotation, and stable mounting, applied with a level of engineering insight we do not traditionally attribute to these eras. To support this view, some researchers turn to an unexpected source: the mythologies of the cultures themselves. In ancient Sanskrit texts from India, there are detailed descriptions of flying machines called vimanas, with intricate specifications that, to some readers, sound less like fantasy and more like technical manuals. In Sumerian cuneiform tablets, the gods are described with objects that produce rays of light or that can level mountains. Mainstream scholarship interprets these as poetic metaphor or religious allegory. But from the alternative viewpoint, these stories could be cultural memories, passed down and distorted over, of real technologies that once existed. They could be the garbled echoes of a time when the line between tool and marvel was far thinner. At its heart, this theory challenges the very backbone of our historical narrative, which is linear progress. It suggests a cyclical view of civilization, where cultures can reach impressive technological heights, only to have that knowledge fragmented and lost due to catastrophe, social collapse, or the simple passage of time. In this light, the great stone monuments are not the proud beginnings of engineering, but the durable remnants of a peak, the last and strongest bones of a forgotten body of knowledge. The granite boxes and precision joints are what remain after everything else. The tools, the blueprints, the understanding has turned to dust. This idea is undeniably controversial, often relegated to the fringes of academia. Critics rightly point out the lack of direct evidence for such machines. No ancient gear or engine has ever been found alongside these stones. The argument rests on interpreting the artifacts as products, inferring the lost tools from their fingerprints. Yet this hypothesis endures because it directly addresses the visceral puzzle the artifacts present. It offers a narrative that explains why the work looks so impossibly precise, why it seems to defy the tools we have found. It transforms the ancient builders from incredibly patient craftsmen into potentially brilliant engineers. And in doing so, it asks us to expand our imagination of what human societies were capable of in the deep, silent chapters of our past. Stones do not change, but the story we tell about them splits into two distinct paths, one of gradual mastery and one of forgotten peaks. The stones themselves point to a mastery of the earth, but what of the sky? The precision we see carved into granite and limestone finds a breathtaking parallel in another ancient discipline: the precise tracking of celestial bodies. This is the realm of archaeoastronomy, and it presents a powerful intellectual counterpart to the physical mystery of the tools. At sites like Stonehenge on the Salisbury Plain, massive stones are arranged not just for grandeur, but as a colossal astronomical calendar. Specific alignments mark the summer and winter solstices, the rising and setting of the sun at the most extreme points of its yearly journey. Far older and more subtle, the stone circles of Playa in the Egyptian desert, dating back over 7,000 years, appear to align with the stars of Orion's belt. These are not casual observations. They represent generations of meticulous night sky watching, the recording of cyclical patterns over lifetimes, and the translation of that abstract knowledge into permanent, monumental form on the ground. This celestial precision forces a compelling parallel. Could the same culture that measured the slow drift of stars with such accuracy, that could predict solar and lunar events years in advance, have been content with crude, unpredictable tools for shaping their world? It seems an intellectual contradiction. The mind capable of such long-term mathematical observation would almost certainly seek that same order and predictability in its craftsmanship. The desire for precision, it seems, was not limited to one domain. It was a cultural value, applied to both the cosmos and the quarry. Nowhere is this marriage of cosmic and earthly precision more evident than in the Great Pyramid of Giza. Its base is almost a perfect square, with sides that vary by mere inches, a feat of surveying that is staggering even today. But more astonishing is its orientation. The sides of the pyramid are aligned to the cardinal directions, north, south, east, and west, with an error of less than a fraction of a single degree. To achieve this, its builders needed to find true north with incredible accuracy, long before the magnetic compass. How did they do it? The likely method involves tracking the circular path of a star around the celestial pole, bisecting the angle to find that fixed point in the sky. This is not simple stargazing. It is a complex, repeated observational technique requiring stable and careful notation. It implies the use of specialized instruments, perhaps a precursor to the transit or theodolite, a tool for measuring angles with high repeatability. Such a device, used for aligning monuments to the heavens, would be a precision instrument in its own right, a sibling to the tools that cut the stone. This intellectual framework deepens further when we look at the mathematics embedded in the architecture. The Great Pyramid's dimensions are famously with the mathematical constant pi, the ratio of a circle's circumference to its diameter. The pyramid's height stands in the same relationship to its perimeter as a circle's radius does to its circumference. The golden ratio, a proportion revered for its aesthetic harmony, appears throughout ancient art and architecture, from the Parthenon in Greece to the proportions of the human body as described by later thinkers. These are not happy accidents. They are signatures of a knowledge system, a shared understanding of geometry and proportion that was considered fundamental to creating order, whether in a building, a statue, or perhaps in the cosmos itself. This suggests the physical precision of the stonework was not an end in itself. It was the practical outcome of a much grander, more holistic vision. The perfect right angle of a stone block mirrored the right angles they used to survey the land. The flawless flat surface reflected their understanding of geometric planes. The mastery over hard stone was the earthly manifestation of their mastery over abstract concepts like number, angle, and celestial cycle. They were building a mirror of a perfect, orderly universe here on Earth, and to do that, they needed tools and techniques that could translate their profound intellectual precision into equally profound physical form. The stones are not just well cut, they are the geometry of a forgotten science. This silent testimony etched in stone now meets the gaze of modern science. To move beyond awe and speculation, researchers are applying a forensic lens to history, treating each artifact as a silent witness waiting to be cross-examined. This is not about grand theories, but microscopic truth. Using tools like high-resolution three-dimensional scanning and electron microscopes, scientists can now examine these ancient tool marks with a clarity our ancestors could never have imagined. They are no longer just looking at a cut in granite. They are mapping its every contour, measuring the depth and angle of each microscopic groove. This allows them to perform a kind of archaeological autopsy, distinguishing with remarkable precision between marks left by different actions. The unique signature of a stone hammer pounding in a percussive blast looks entirely different under magnification than the long, parallel striations of a saw dragged back and forth. Even more telling, the very profile of a saw mark, the shape of the groove it leaves behind, can act like a fingerprint. A deep, V-shaped groove might suggest a softer metal blade that deformed under pressure, while a cleaner, U-shaped profile could hint at a harder, more rigid cutting edge. The direction and consistency of these microscopic striations tell a story of motion. Were they created by a simple back-and-forth reciprocating saw, powered by human muscle, Or do they show the unidirectional, continuous flow of marks that might suggest a rotary blade or a mechanically stabilized cutting process? Similarly, the study of drill holes has been revolutionized. By analyzing the spiral grooves on a core, scientists can calculate the feed rate, the consistent speed at which the drill advanced into the stone. They can also examine the abrasive slurry itself, or rather, its fossilized remains. The wear patterns on the tiny quartz or emery particles embedded in the stone can reveal their size, hardness, and even how they were applied, whether they were loose and chaotic or bound into a more controlled cutting medium. This scientific scrutiny transforms the debate. It moves us from asking what do we think happened to what does the physical evidence actually say happened. Each scan, each microscopic image, generates hard data. This data can powerfully support conventional theories, showing how patient abrasion with sand and copper could indeed create these objects over immense. But it can also reveal stubborn anomalies, features in the stone that do not match the expected pattern of simple hand tools. A cut that is too deep and uniform, a drill core spiral that is too mechanically perfect, a surface polish that lacks the microscopic scratching of sand. These are the clues that demand new explanations. In this light, every granite box, every inscribed pillar becomes a cold case file. The stone is the scene, the tool marks are the evidence, and we are the detectives, armed with technology our predecessors lacked, trying to listen to a story told in whispers 1/100th of a millimeter wide. The truth is in the details, and we are only just beginning to hear them clearly. Perhaps the most compelling question is not how they achieved such precision, but why they felt it was necessary in the first place. Why dedicate lifetimes to polishing the interior of a stone box that would be sealed in darkness forever? Why engineer the flawless fit of a 100-ton block when a simpler, rougher joint would have sufficed for structural integrity? The answer may lie not in the realm of engineering, but in the realm of meaning. For many ancient cultures, the act of building was not just a practical task, it was a sacred dialogue with the cosmos. Perfection in construction was often a religious or cosmological imperative. A perfectly smooth, polished surface of granite might have been intended to capture and reflect divine light, or to represent the primordial waters of creation. The precise cardinal alignment of a pyramid was not a display of surveying skill for its own sake. It was a tether, a way to anchor the earthly structure to the eternal, unchanging order of the stars. In this worldview, a building was more than a shelter or a tomb. It was a model of the universe, a microcosm. Its perfection mirrored the perceived perfection of the gods and the heavens. Any flaw, any irregularity was not merely a technical error, it was a spiritual rupture, a failure to correctly replicate the divine blueprint. This symbolic dimension transforms our understanding of the immense effort involved. The decades of labor, the generations of artisans, the unfathomable patience were not allocated to solve a technical problem, but to fulfill a sacred duty. The drive for precision was culturally embedded and spiritually motivated. It was an act of devotion, a form of worship expressed through geometry and stone. This explains why a society would pour its resources into achieving results that seem, from our modern, efficiency-obsessed perspective, technologically disproportionate. The value was not in the time saved, but in the perfection attained. The flawless joint was a prayer. The mirror-like polish was an offering. The structure that aligned with the solstice sun was a conversation with the divine. When we look at these ruins and see only a puzzle of lost technology, we might be missing half the story. We are seeing the physical evidence of a profound spiritual and intellectual ambition, a desire to build eternity itself, one perfect stone at a time. A perfectly carved stone is only half the story. Its journey from the quarry to its final resting place forms the second, equally staggering chapter of this ancient mystery. We must now confront the transportation conundrum. How did cultures, often without the wheel or draft animals, move multi-ton blocks of exquisitely finished stone across miles of rugged terrain and then position them with millimeter-perfect accuracy? Consider the staggering scale of the task. In the Lebanese mountains lies the Baalbek Terrace, home to the 3 limestone blocks each estimated to weigh over 800 tons. That is the equivalent of 2 fully loaded jumbo jets. Nearby lies an even larger monolith, partially weighing an almost incomprehensible 1,600 tons. In Egypt, obelisks and massive granite columns weighing hundreds of tons were transported hundreds of miles from their quarries in Aswan to temples in Luxor and beyond. These were not rough-hewn boulders, they were finished products, their surfaces already polished, their edges sharp, their geometry precise. Bumping or dragging such a stone carelessly would shatter a corner, ruin a polish, or a critical joint. The move had to be as flawless as the craft. Mainstream archaeology provides a well-documented toolkit for this puzzle, a symphony of simple machines and organized labor. The principles are clear, wooden sledges sliding on lubricated tracks of wet clay or mud, armies of workers pulling with ropes. The use of rollers, either wooden logs or specially shaped stone cylinders, placed beneath a sledge to reduce friction. The construction of massive earthen ramps, rising gradually to lift stones into position on rising temple walls. We even have ancient illustrations, like the famous scene from an Egyptian tomb showing a colossal statue being moved on a sledge by hundreds of men, with a foreman pouring a liquid, likely water, ahead of the runners to reduce friction. The explanation is logical, demonstrable, and grounded in immense human effort. It tells a story of social organization so powerful it could redirect rivers of manpower toward a single, awe-inspiring goal. Yet, when you stand before the at Baalbek, the sheer logistics whisper a persistent doubt. Moving an 800-ton block from its quarry over uneven ground, and then lifting it over 20 feet to sit perfectly aligned on a prepared foundation, using only ropes, logs, and ramps, pushes the envelope of what we can comfortably envision. The margin for error is zero, the coordination must be perfect, and the risk of catastrophic failure is immense. This gap between the plausible method and the monumental result has fueled alternative speculation. Could there have been a lost principle that made the task easier? Some point to intriguing, if ambiguous, clues in mythology. Stories from various cultures speak of stones that were made to move by sound, of magic words or chants that could lighten a load. To a modern mind, this sounds like pure fantasy, but could it be a garbled cultural memory of a sophisticated technique? The speculative idea of acoustic levitation, using resonant sound waves to reduce friction or even counteract weight, is a fringe theory that captures the imagination, though it lacks any physical evidence from the archaeological record. It represents a deep human desire to solve the puzzle with an elegant, lost science rather than brute force. Perhaps the most profound insight lies not in choosing one theory over the other, but in recognizing what the successful move itself represents. The seamless combination of precise fabrication and precise placement points to a holistic, systemic mastery. It was not enough to know how to cut stone perfectly. You also had to know how to move it without damaging that perfection, and how to place it so that perfection became part of a larger, stable whole. This implies a unified body of knowledge, a school of thought that encompassed materials science, logistics, civil engineering, and crowd management. It suggests the existence of master architects who could think in 4 dimensions, planning the cut in the quarry, the route across the desert, and the final fit in the wall, all as parts of a single, grand equation. The stone's journey, therefore, becomes the ultimate test of that knowledge. A single cracked block abandoned along a transport road is a monument to failure. A 1,000-ton stone set perfectly in place is a monument to a system that worked, a system whose complete workings, its tricks of leverage, its secret lubricants, its precise commands, remain just as silent as the tools that shaped the stone in the first place. The scattered echoes of this precision now force a profound question upon us. Do these similar feats of stonework, found on continents separated by vast oceans, point to a shared teacher, or do they reveal something fundamental about the human mind itself? This is the great debate between cultural transmission and independent invention. On one hand, the similarities can be breathtaking. Look at the polygonal masonry found in the Inca walls in Peru, the Cyclopean foundations of ancient Greek sites like Mycenae, and even certain enigmatic structures in Japan. All feature massive, irregularly shaped stones fitted together with such tight, interlocking joints that a blade cannot slip between them. The visual resemblance is uncanny. It is tempting to see a thread connecting them, a single lost source of knowledge carried by ancient seafarers or a forgotten progenitor civilization that seeded these techniques across the world. This idea of a primordial master culture is a powerful narrative, offering a neat solution to a global puzzle. Yet the evidence is not so straightforward. While the results look similar, the methods and styles often differ in telling ways. The specific artistic motifs, the types of stone used, the overall architectural language, these are distinct, deeply rooted in local culture and environment. More importantly, a compelling alternative exists: convergent evolution. Just as birds, bats, and insects all independently evolved wings for flight, different human societies, when faced with the same universal challenges, may have independently arrived at similar, brilliant solutions. The primary challenge for many of these cultures was seismic activity, living in earthquake-prone regions. A wall built with standard, rectangular blocks stacked in rows has a clear point of failure: the straight, continuous mortar joints. When the ground shakes, these lines become cracks and the wall collapses. But a wall built with polygonal, interlocking stones is a different beast. Each stone is locked in place by the unique shapes of its neighbors, creating a flexible, dissipating structure that can shift and settle during a tremor without catastrophic failure. It is a supremely logical answer to a common environmental threat. This principle extends beyond earthquake resistance. The human drive to build something monumental and eternal, whether a temple, a fortress, or a tomb, universally demands solutions for stability, precision, and longevity. The mind, when focused on that goal, will naturally explore geometry, leverage, and material science. The invention of precise measurement, the development of controlled cutting techniques, the concept of dry stone fitting, these are not magical secrets. They are logical progressions of observation, trial, and error, refined over generations. So which perspective is true? The answer likely lies not in choosing one, but in embracing a more complex tapestry of human history. Some knowledge certainly traveled along trade routes, through contact and exchange. A clever technique for moving stones or checking a level could spread from one culture to another, adapted to local materials and needs. Yet the core spark of ingenuity, the capacity to look at a mountain and see a quarry, to look at a star and see an alignment, this is innate. It speaks to a shared human capacity for profound innovation that can ignite in isolation, given enough time, motivation, and need. The stones, therefore, are not proof of a single lost civilization, but rather a collective testament. They are monuments to the incredible and sometimes parallel paths the human mind can take when reaching for permanence, reminding us that genius is not a secret to be hoarded, but a potential waiting to be unlocked again and again across the span of our shared story. History is rarely a straight line. It is a story punctuated by profound fractures, moments when the thread of knowledge is not merely stretched, but severed. Around 1200 BCE, the vibrant, interconnected civilizations of the Eastern Mediterranean, from the Mycenaean Greeks to the Hittite Empire, experienced a sudden and catastrophic unraveling known as the Late Bronze Age collapse. Palaces burned, trade routes vanished, and crucially, the skill of writing itself was lost in many regions for centuries. This was not a gradual forgetting, but an amnesia, where advanced administrative and artistic techniques simply disappeared from the record. If such a reset could happen to complex, literate societies in the relative blink of an eye, it forces a deeper, more unsettling question. Could earlier, more devastating events have erased even more foundational knowledge from the human story, knowledge we now only glimpse in the silent perfection of ancient stone. Proponents of the lost technology hypothesis look to this pattern and see a potential explanation for our deepest mysteries. They point to the geological record, which shows our planet is no stranger to violent change. Massive volcanic eruptions can cloak continents in ash, triggering years of famine. Rapid shifts in climate can turn fertile lands into deserts, scattering populations. There is even compelling evidence for catastrophic flooding events in our distant past, from the filling of the Mediterranean Sea to regional deluges caused by melting ice sheets at the end of the last ice age. These are not speculations, but events documented in ice cores and sediment layers. And intriguingly, these physical echoes find a parallel in the stories humans have told for. Cultures across the globe, from the Mesopotamian epic of Gilgamesh to flood narratives among indigenous peoples of the Americas, preserve a shared memory of a great deluge, a world-altering flood that cleansed the land. Mainstream scholarship interprets these as allegorical tales or memories of local disasters. But from an alternative viewpoint, they could be the cultural scar tissue from a real, global catastrophe. The logic of this hypothesis is starkly simple. Imagine a society, perhaps not global but regionally advanced, that had developed a sophisticated understanding of geometry, mechanics, and materials. Their knowledge was not stored in vast digital libraries, but in the minds of master craftsmen and the oral traditions of guilds. Then, a cataclysm strikes, whether a flood, a volcanic winter, or a rapid climate shift. The social order shatters. Populations are decimated or scattered into survival mode. In the desperate struggle for food and shelter, the meticulous art of shaping granite with perfect precision becomes not a priority, but a forgotten luxury. The specialized tools decay. The master artisans, the living repositories of that knowledge, pass away without apprentices to teach. Within a generation or two, the how vanishes. Only the what remains, the indestructible products of that knowledge, the stone monuments themselves, standing amid the ruins of a world that no longer understands how they were made. This creates the exact archaeological puzzle we face today, a landscape of effects without clear causes. We are left with the flawless boxes but no workshop diagrams. We have the interlocking stones of Puma, but no legends of the engineers who designed them. The most durable creations become orphaned artifacts, masterpieces without a signature, their very perfection a taunting clue to a context that has been washed away. This perspective does not require aliens or magic, only the sobering recognition of how fragile human knowledge can be when it is not embedded in resilient, widespread systems. It suggests that progress is not inevitable, that the ladder of technology can sometimes slip, and that we may be looking at the scattered, monumental wreckage not of humanity's clumsy beginnings, but of a peak from which we long ago fell, leaving us to rebuild and to wonder from the foundations up. The theories are compelling, but the true test lies in the workshop. To move beyond debate, a handful of dedicated modern stoneworkers have taken up the ultimate challenge, attempting to recreate these ancient masterpieces using only the tools and materials we believe were available. These are not thought experiments, they are physical trials, where theory meets the unyielding resistance of granite. The results are a fascinating mix of triumph and stubborn mystery. In one well-documented experiment, a skilled artisan equipped with a simple bow drill, a hollow copper tube, and an abrasive slurry of quartz sand and water, successfully drilled a hole into a block of granite. The process worked, proving the fundamental principle of abrasion is sound. But the data from this success is just as telling as the result itself. Drilling a hole just a few inches deep required not minutes, but dozens of grueling, monotonous hours of constant labor. The feed rate was painfully slow, and maintaining perfect vertical alignment with a handheld tool was a constant battle against wobble and fatigue. Other attempts to replicate the famous mirror finishes have had mixed outcomes. Using progressively finer abrasives, From sand to powdered emery, craftsmen can achieve a very high polish, a beautiful luster that seems to confirm the patient artisan model. Yet, when placed side by side with an original artifact, subtle differences often remain. The modern polish might show a faint, overall haze of microscopic scratches, while the ancient surface can appear deeper, more liquid, as if the stone itself had been melted and into a perfect plane. The most significant gap, however, emerges in the realm of complex geometry and scale. While a single artisan can, with immense time, create one perfectly flat surface or one symmetrical vase, the challenge of producing dozens of identical, complexly shaped blocks like those at Puma, or of achieving the flawless interior right angles of the boxes, remains largely unmet by these experimental methods. The time and labor required would scale to almost mythical proportions. These modern replications are invaluable because they establish a clear baseline. They show us what is demonstrably possible with simple tools, incredible patience, and human skill. They give weight to the conventional narrative, but in doing so, they also cast the anomalies of the ancient world into even sharper relief. The experiments highlight the severe limitations of these methods in terms of efficiency, repeatability, and the achievement of certain specific geometries. They do not definitively prove how it was done, but they help us measure the gap between what we can recreate with our understanding of their tools and what they indisputably achieved. This gap is not an empty space. It is a question carved in stone, waiting for a better answer. The conversation about these ancient stones exists in a world of noise as well as signal. It is a field magnetically drawn to sensational claims, where whispers of lost continents and impossible machines often drown out the quieter, more patient voice of evidence. This is the realm of a shadow that has long stretched across genuine inquiry, and its influence cannot be ignored. For every legitimate researcher measuring tool marks under a microscope, there are popular narratives that leap straight to ancient astronauts or antediluvian supercivilizations, weaving compelling stories that often ignore the foundational principles of archaeological context. These narratives thrive on mystery, but they frequently do so by discarding the very methodology that could solve it. The consequences are twofold. First, they create a distorted public perception, setting expectations for a single, magical answer to every anomaly. Second, and perhaps more damagingly, they provoke a defensive backlash from the academic mainstream. When outlandish claims are presented with the same confidence as peer-reviewed papers, it becomes easier for some scholars to dismiss the entire conversation, to lump all challenging questions into the category of fantasy. This creates a polarized landscape where asking how a specific granite box was polished can be misconstrued as endorsing a fictional history. This is why developing a critical eye is not just helpful, it is essential. As viewers and thinkers drawn to this mystery, our most important tool is discernment. We must learn to evaluate sources. Is an idea supported by physical data published in a scientific journal, or is it primarily promoted through slick documentaries and popular books with few footnotes? Are artifacts presented with their full provenance, where and how they were found, or do they appear as isolated, miraculous objects? Understanding basic archaeological methodology, the painstaking process of stratigraphy, carbon dating, and comparative analysis, allows us to see the difference between a grounded hypothesis and a flight of fancy. The genuine artifacts from the and Puma present a mystery that is profound enough on its own. They do not need aliens or Atlantis to be astonishing. Their true story, once uncovered, will be a human story, and likely all the more remarkable for it. Our goal, then, is to navigate a thoughtful middle path. We must avoid the trap of rigid skepticism that refuses to ask new questions simply because they challenge textbook summaries. But we must equally avoid the lure of uncritical belief that accepts any answer as long as it feels thrilling. The most rewarding journey lies between these poles, guided by a simple, disciplined mantra: follow the evidence. This means being willing to let go of a favorite theory if the data does not support it, and being brave enough to pursue a legitimate anomaly even when it makes experts uncomfortable. The stones have waited for thousands of years. They can wait a little longer for us to learn how to listen properly. Two different experts can look at the same stone box and see two entirely different stories. This is the power and the challenge of interdisciplinary dialogue. When a trained engineer examines the interior corner of a granite sarcophagus their mind does not automatically think of ritual or symbolism. Instead, it analyzes process. That flawless right angle and glass-smooth surface present as a series of technical constraints. To achieve that, the cutting tool must have been incredibly stable, applying even pressure without any wobble, what machinists call a lack of tool chatter. The consistent depth of cut across the entire plane suggests a controlled mechanical feed rate. To an engineer, these features are the unmistakable fingerprints of a fixed, guided tool, something that provides stability and repeatability far beyond what human hands alone can manage. It looks, in a word, machined. A geologist, meanwhile, approaches the same box from a different angle. Their focus is on the material itself. By studying the crystalline structure of the granite, they can understand its fracture mechanics, how it breaks under stress. They can identify the specific minerals within the stone and predict which abrasive materials would be effective against it. They might examine the microscopic wear patterns to determine the direction and type of force applied. Their analysis is rooted in the immutable laws of physics and material science, providing a bedrock of what is physically possible. The archaeologist, holding the cultural context, then enters the conversation. They bring the timeline, the knowledge that this box was created in a pre-industrial society, and the understanding that for the people who made it, this object held profound spiritual meaning. The extreme effort required was not a technical hurdle to be optimized, but a devotional act to be perfected. What the engineer sees as a problem of mechanics, the archaeologist sees as an expression of faith. This is not a conflict to be won, but a synthesis to be built. The engineer's perspective highlights the technical anomalies that demand explanation. The geologist provides the hard limits of the material world. The archaeologist insists we remember the human hearts and minds behind the work. The truth of these artifacts likely lives in the space where all these insights overlap. Perhaps the solution is not a single, lost machine, but a forgotten sophistication in applying simple principles. Could a culture with a deep, ritual drive for perfection have developed ingenious jigs, guides, and compound tools that provided mechanical advantage? Tools so specialized they left no trace because they were made of wood or worn-out copper, recycled long ago. The engineer's impossible and the archaeologist's extreme effort might converge on a third, more fascinating reality, a pinnacle of pre-industrial ingenuity that we are only beginning to appreciate. By listening to all these voices, we stop looking for a single magic answer and start building a richer, more respectful understanding of what our ancestors truly accomplished. The silence of the tools themselves is a profound part of the mystery. If these methods were so advanced, where is the physical evidence, the chisels, the saws, the machines? For conventional archaeology, this absence is a powerful argument. The most straightforward explanation is that the tools were exactly what we have always found: simple copper, stone, and wood implements, worn down to nothing and lost to time. Metals like iron, if ever used in these deep antiquity contexts, would have long since oxidized into dust. But this logical answer bumps against the persistent questions raised by the artifacts. If the tools were so simple, why do their results sometimes seem so complex? The search for an answer has led researchers down several fascinating, if speculative, paths. One possibility is that the tools were not lost, but recycled. In a world where metal was incredibly valuable, a worn-out copper saw blade or a broken drill bit would not be thrown away. It would be melted down and reforged into a new tool or into jewelry or a weapon. The original tool ceases to exist, its material living on in other forms, leaving no direct fingerprint for us to find thousands of years later. Similarly, specialized jigs or frames made of wood, crucial for guiding cuts and ensuring precision, would have rotted away centuries ago, leaving only their perfect stone products behind. Another compelling idea shifts the focus from the tool to the substance. Perhaps the key innovation was not a revolutionary machine, but a revolutionary material. Could ancient artisans have developed a specialized abrasive compound, a paste or slurry far more effective than simple sand? A mixture that contained a secret, harder mineral, or a chemical agent that reacted with the stone surface to make it easier to work. Such a substance, once used up, would leave almost no trace, especially if its container was perishable. Some researchers have begun analyzing the microscopic residues left in the cut marks of ancient stone, searching for unusual mineral signatures or chemical alterations that might hint at a forgotten formula. This line of inquiry moves the mystery from the workshop bench to the alchemist's shelf. Even more speculative are the theories that propose the tools were not solid at all. The persistent legends across cultures of stones moved by sound or song have inspired a fringe but enduring question. Could acoustic resonance, the focused power of specific sound frequencies, have been used to soften stone or reduce friction during cutting and moving? While no scientific evidence supports this as a practical ancient technology, the concept highlights a broader truth. Our search is limited by our own assumptions of what a tool must look like. We expect to find a hammer, a saw, a drill. But what if the tool was a process, a carefully guarded sequence of steps involving heat, cold, specific liquids, and precise timing, a recipe that transformed the stone's workability temporarily? Such a technique would leave no durable artifact for an archaeologist's trowel to uncover. It would reside solely in the knowledge passed from master to apprentice, a knowledge infinitely more fragile than granite. When that chain of transmission broke, the technique would vanish as completely as a whisper in the wind, while the stones it shaped would endure forever. This search, therefore, becomes an exercise in humility. It asks us to consider that the most sophisticated tools of the ancient world may have been ideas, not objects, leaving us to decipher their existence solely through the impossible geometry they left behind. A firm date is the anchor point for every historical mystery. Without it, we are adrift in speculation. This is where the investigation into ancient precision confronts one of its greatest challenges: the complex and often conflicted chronology of the sites themselves. A temple or monument is rarely a single event frozen in time. It is more often a living document in stone, built, expanded, renovated, and sometimes repurposed over hundreds or even thousands of years. A single wall might contain blocks carved in vastly different eras. So when we stand before a wall of impossibly fitted polygonal masonry or a chamber of flawlessly polished granite, a critical question arises. Are we looking at the original foundation or a later repair? Could that one perfect block be a later insertion, a skilled restoration from a more advanced period slipped into an older, cruder structure? Disentangling this timeline is the work of forensic history. Radiocarbon dating is a powerful tool, but it has a specific limitation. It dates organic material. If we find a piece of charcoal or a bone fragment in the mortar between two stones, we can date when that mortar was mixed. That tells us when those stones were set, which is invaluable. But it does not tell us when the stones themselves were shaped. They could have been carved centuries earlier and simply used in a later construction phase. Thermoluminescence can date the last time a piece of pottery was fired, offering another clue from associated artifacts. Yet for the stonework itself, the primary method is stratigraphy, the careful analysis of layers. Archaeologists meticulously excavate, noting which layer of soil and debris sits atop another, which wall foundation cuts through an older floor, which artifact is sealed beneath an unmoved stone. This painstaking work builds a relative sequence, a story of what came before what. But sometimes, the story told by the stones clashes with the story told by the established timeline. This is the chronological anomaly. A specific artifact, with its unmistakable signature of high precision, is found in a stratum dated to a period when, according to mainstream understanding, the technology to create it should not have existed. The precision feels anachronistic, like finding a stainless steel screw in a medieval castle. Resolving these conflicts requires a rare blend of rigor and intellectual flexibility. It demands that excavators be meticulous, ensuring a discovered object is truly in its original context and not the result of later disturbance. But it also requires the broader academic community to be willing to reevaluate long-held assumptions when new, well-documented evidence emerges. Perhaps a site is older than we thought. Perhaps a cultural peak of technical skill occurred earlier and was then forgotten, leaving only these scattered, durable echoes. The historical narrative is not a rigid script. It is a fluid manuscript, constantly being edited by the trowel and the microscope. Each precisely dated layer, each reconciled anomaly, brings us one step closer to hearing the true story these stones have been waiting for to tell. These stones do more than puzzle archaeologists. They captivate something fundamental within us. The mystery of their precision resonates not merely as a technical riddle, but as a profound psychological echo. It directly confronts the comforting, linear narrative of history we have all inherited, the story of a steady climb from primitive beginnings to our modern pinnacle. That story is tidy and reassuring, placing us securely at the top of an evolutionary ladder. But what if the ladder has missing rungs, or worse, what if it occasionally curves back on itself? The suggestion that ancient builders might have possessed a slice of knowledge, a technique or understanding that has since slipped through the fingers of time, is a deeply destabilizing and exhilarating thought. It is a humbling reminder that progress is not a one-way street, and that civilizations, along with their wisdom, can recede as well as advance. This taps into a powerful sense of lost grandeur, a romantic notion of a golden age whose technological and spiritual heights we can no longer fully grasp. We look at the seamless joints of Puma or the mirror finish of a granite box, and we do not just see well-made objects, we see ghosts of a forgotten confidence, a mastery that whispers we may have once known more than we do now. This realization carries a subtle warning about the fragility of knowledge itself. In our digital age, we assume information is permanent, backed up on servers around the globe. But these stones testify to a time when knowledge lived in the minds of masters and the practices of guilds, vulnerable to the chaos of natural events, social collapse, or the simple passage of generations. A single cataclysm, one broken chain of apprenticeship, and an entire library of practical wisdom could vanish, leaving behind only its most durable products as cryptic monuments. This inherent fragility makes every surviving artifact feel like a miracle, a message in a bottle washed up from a sunken continent of thought. It is no wonder, then, that this mystery has become such fertile ground for the imagination. It fuels endless speculation, from rigorous academic papers to popular documentaries and best-selling novels. It inspires amateur sleuths with calipers and engineers with software to take their own measurements, to propose their own theories. This widespread fascination is not a distraction from the real inquiry. It is the engine of it. That collective drive to solve the puzzle, to fill that tantalizing gap in the human story, pushes both the dedicated enthusiast and the tenured professor to keep looking, to keep questioning established narratives. The stones themselves are silent, but they represent the ultimate open-ended question. They are an enduring invitation to wonder, a permanent reminder that the past is not a closed book with a fixed ending, but a vast, partially lit landscape where new discoveries can always rewrite the map. Our captivation, therefore, is not just about how they cut the stone, but about what their existence says about us, about our desire to find our place in a story that is far deeper and more mysterious than we ever supposed. This growing fascination carries a hidden danger, a race against time not just for answers, but for the survival of the evidence itself. As more eyes turn toward these ancient sites, the very clues that could solve the mystery become increasingly vulnerable. The threat is threefold, ranging from the criminal to the careless. Looters, driven by the black market value of antiquities, can ravage a site in a single night, tearing apart stratigraphic layers and destroying the context that gives an artifact its meaning. A stolen vase is a tragedy, but the shattered relationship between that vase and the floor it sat on is a lost chapter of history. Then there is the wear of unmanaged tourism, where thousands of footsteps can erode ancient surfaces, and the oils from countless hands touching a precise stone edge can degrade microscopic tool marks over decades. Perhaps most complex is the risk from investigation itself, from well-meaning but outdated or hurried excavation techniques that, in the quest for a spectacular find, might bulldoze through subtle soil variations or discard material considered unimportant, material that future science could analyze in revolutionary ways. This precarious reality has forged a new ethic in modern archaeology, one that fundamentally shifts the priority from discovery to stewardship. The guiding principle is simple yet profound: preservation first. Often, the most responsible action is not to dig at all, but to listen. Today's researchers are increasingly turning to non-invasive eyes. Ground-penetrating radar sends pulses into the earth, mapping buried structures without moving a single grain of soil. LiDAR scanners mounted on planes peer through dense jungle canopy to reveal the ghostly outlines of entire cities hidden below. High-resolution three-dimensional laser scanners can create a perfect digital twin of a monument or artifact, capturing every detail down to a fraction of a millimeter, a record that will last long after natural erosion takes its toll. These techniques allow scientists to ask questions, to plan, and to understand a site's full scope before any physical intervention is considered. When excavation does proceed, it is with the delicacy of a surgical procedure, each layer documented with photographs, drawings, and precise coordinates, every speck of soil sieved for microscopic clues like pollen, seeds, or traces of metals. This meticulous, cautious approach may seem frustratingly slow, especially when the mysteries are so tantalizing, but it is built on a profound respect for the artifact as a non-renewable source of information. We are not just uncovering objects, we are decoding a single, irreplaceable message from the past. The true key to understanding how these stones were shaped may not be a grand new theory, but a single, unremarkable tool mark on a buried block, waiting for a scanner not yet invented to reveal its secrets. It may be a tiny residue in a crack, analyzable by a chemical technique developed next decade. By protecting these sites, we are not delaying the answer. We are preserving the question for a future generation of thinkers who will bring tools of analysis we cannot yet conceive. The greatest act of discovery, then, might be the patience to wait, ensuring the stones can speak clearly when we are finally ready to hear them. The silent stones may soon find their voice through tools we are only now learning to build. The key to unlocking their secrets likely rests not in the dusty past, but in a future rapidly taking shape within our laboratories and computer servers. We stand at the threshold of a new kind of archaeology, one where the questions posed by ancient precision may finally meet the analytical power needed to answer them. Imagine a future where every tool mark on every granite box, every spiral groove on every drill core is not just photographed, but scanned in microscopic detail and fed into a vast, global database. This is where artificial intelligence enters the story, not as a science fiction trope, but as a practical, pattern-finding partner. An AI system could analyze millions of these digital fingerprints, comparing a cut from Puma with one from Giza, a polish from Malta with one from Baalbek. It would search for patterns of similarity in the angle, depth, and striation that are simply too subtle or too vast for any human researcher to ever perceive across continents. It could categorize styles of workmanship with objective precision, potentially tracing the migration of a specific technique across time and space, or identifying clear technological shifts that signal the use of a new tool or method. Beyond the surface, even more revealing technologies await. Advanced spectrometry, which analyzes the interaction between matter and light, could be trained on the stone itself. It could detect residues so minute they are invisible to any microscope. The chemical ghosts of ancient workshops was a unique binding agent mixed with the abrasive slurry to make it more effective. Did they use a specific plant oil that reacted with the stone to ease polishing? A spectrographic analysis might find the molecular signature of that lost recipe right on the artifact's surface, a recipe that never made it into any written record because it was passed from master to apprentice as a guarded secret. Then there is neutron imaging, a technology that sounds like it belongs in a particle physics lab, and it does. Unlike X-rays, which are blocked by dense materials, neutron beams can pass through thick stone with ease, sensitive to different elemental compositions. This means we could peer inside a sealed stone vessel from ancient Egypt, or look into the core of a massive blockade without causing the slightest damage. We might discover internal flaws, hidden repair work, or even the remnants of the tools themselves if a broken drill bit was ever left inside a drill hole. We could see how stone was joined internally, understanding the structural logic in 3 dimensions. The promise of these emerging tools is profound. They shift the paradigm from interpretation to interrogation. We are moving from looking at an artifact and asking what do we think this is, to asking the artifact directly and receiving an answer in the form of hard, empirical data. The stone becomes a witness we can finally cross-examine with a sophisticated and growing toolkit. This data-driven approach has the power to transform decades of passionate debate into a framework of settled, reproducible facts. It can distinguish between what was possible with simple tools and immense patience, and what truly required a more sophisticated mechanical process. The romantic speculation and the cautious orthodoxy could converge on a detailed, evidence-based narrative of ancient innovation. The next decade of research holds this transformative potential. As these technologies become more affordable and accessible, they will move from exclusive labs to university archaeology departments and even field sites. The silent stones, patient for, may finally be ready to tell their story not in whispers, but in a clear language of data, revealing the lost footsteps of the artisans who shaped our world from the very bones of the earth. The journey through these silent stones leaves us with a spectrum of possibilities, each compelling in its own way. To find clarity, we must now weigh the evidence, holding the orthodox and the speculative in balance to see where the scales might settle. On one end rests the powerful argument of supreme human skill. This view sees the monuments as testaments to cultural will, where generations of artisans, armed with simple copper and stone tools, an endless supply of abrasive sand, and an ocean of time, achieved the impossible through sheer, undiluted dedication. The evidence from experimental archaeology supports this, proving that patience can indeed carve granite. The social structures of early civilizations could marshal thousands, turning a sacred project into a multi-generational endeavor where perfection was the only acceptable offering to the gods or the ancestors. This explanation is elegant, human-centered, and fits within the established timeline of our history. It tells a story we understand, one of gradual mastery and profound spiritual commitment. Yet at the other end of the spectrum, the anomalies whisper of something else. The machine-looking drill cores, the flawless interior right angles in granite, the systematic, interchangeable stonework of Puma, these details persistently strain the patient artisan model. They point toward mechanical consistency, repeatability, and control that feel, to a modern eye, technological. This has fueled the more speculative theories of lost high technology, or even a forgotten progenitor civilization whose advanced knowledge was fragmented by some ancient catastrophe. While these ideas capture the imagination, they often leap over the lack of direct evidence, the missing tools, the absent blueprints, and can dismiss the incredible capacities of human ingenuity itself. Perhaps The most illuminating path forward lies not at the extremes, but in the nuanced space between them. This middle path suggests we have underestimated not the existence of advanced machinery, but the sophistication of optimized technique. Imagine a society that, through generations of focused experimentation, discovered a superior abrasive compound, a paste far more effective than simple sand. Perhaps they mastered the use of specific plant extracts that temporarily altered the surface hardness of stone. Maybe they developed compound tools and ingenious jigs, precursors to the lathe or drill press, crafted from wood and rope that provided remarkable mechanical advantage. A bow drill, for instance, is a simple machine, but its mastery represents a profound leap from percussive pounding to controlled rotation. What if these cultures achieved a temporary, localized peak in such applied mechanics, a golden age of stoneworking that was a closely guarded secret of a master guild? This middle path resolves the tension elegantly. It acknowledges the physical anomalies as the products of specific, highly refined methods, without requiring a complete rewriting of history or invoking global cataclysms. It allows for the possibility that ancient innovators could discover and perfect a technique that gave them a temporary technological edge, a way to interact with stone that was later forgotten not in a single disaster, but through the normal, slow attrition of knowledge. When a guild dissolves, when a social order shifts, when priorities change from monument building to survival, specialized knowledge can evaporate within a few generations. The tools, often made of perishable wood or recyclable metal, vanish. The secret formulas are lost. All that remains are the durable products, the stone masterpieces that stand as orphaned marvels, their context dissolved by time. This view honors both the incredible skill of the artisans and the stubborn puzzles they left behind, suggesting that the truth of our deep past is not a single story of linear progress, but a tapestry of brilliant, sometimes isolated, peaks of human ingenuity that rose and faded long before the age of writing began to record their methods. The stones have spoken, not with words, but with geometry. The traces of precision tools in ruins older than writing are far more than archaeological curiosities. They are profound, enduring challenges to our historical imagination. They do not fit neatly on our timeline, and that is their greatest gift. They force us to reconsider the narrative we have all been taught, the simple story of a slow, steady climb from primitive beginnings to our modern technological peak. These artifacts stand as stubborn proof that the human story is infinitely more complex, wonderfully nonlinear, and still brimming with surprises waiting to be uncovered. Whether the final explanation lies in the relentless patience and genius of ancient master artisans, or in the faint, haunting whisper of a technology that slipped through the cracks of time, the ultimate lesson is the same. These stones compel us to remain humble and perpetually curious. They are a permanent reminder that our understanding of the past is always provisional, always subject to revision with the next discovery, the next scan, the next question asked from a new perspective. History is not a closed book gathering dust on a shelf. It is a living, breathing puzzle, and we are all piece fitters, trying to see the grand picture from the fragments that have survived. As we reach the end of this exploration, the most meaningful question may not be for the experts, but for you. When you look at these images, when you contemplate these perfect cuts in impossible stone, what do you see? Do you see the ultimate pinnacle of primitive skill, a testament to what human hands can achieve with nothing but time and devotion? Or do you see the ghost of a forgotten world, a silent echo from a chapter of our story that was lost before the first word was ever written? There is no single right answer, only the conversation that these mysteries inspire. Share your thoughts in the comments below. Let us continue the discussion. If this journey into the depths of ancient mystery has captivated you, consider subscribing for more explorations into the unknown corners of our shared past. The stones have waited for. They are patient. They will keep their secrets a little longer, but the past still has profound secrets to tell, and together we can learn how to